Hello, puppies and kittens, and we are in preparation for the expedition that we're going on to in Wyoming here in a couple of weeks. I was talking to my wife about what sort of fossils we would be looking for, and while she is pretty well on the ball with those, even though this is not her area of study, whenever I mention any other people that I'm going to be up in Wyoming in a couple of weeks or whatever, and what are you doing? Well, I'm going to go hunt for fossils. Oh, you mean dinosaurs? No, this is Eocene, so it's too recent for dinosaurs, and nobody knows what Eocene means. It seems when you talk to the common laity, they have this idea of there's two pieces of time. There's Flintstones time, where there are people and dinosaurs, and then there is now time, where there's people in Loch Ness Monster and all the dinosaurs have gone into hiding. That seems to be one way to look at it. I got into an argument really with a mechanic. I said, I need to prep my Jeep for this expedition. I want to get this, make sure these things are taken care of because I'm going off road for a couple of weeks. What are you doing? I'm hunting for fossils. You're looking for fossils? You mean like dinosaurs? Oh, because that's what they always say. And I say, no, that's Eocene, so it's too recent. And then right away I get, what do you believe? I'm a little confused at that, because I could easily ask the mechanic, well, what do you believe? And does that change the fact that the fossils are there? Does your belief have any impact over the existence of the fossils, or the implication that they are signs of animals that used to wander around that we don't have anymore? What does belief have to do with anything? But anyway, nobody knows what the Eocene is, and that's the point I'm going with there. So I have with me, as I was looking for Donald Prothero, who I guess can't make it tonight. He was supposed to, but I haven't been able to raise him. So maybe there's a conflict. Maybe there's a problem with the calendar. I don't know. But I do have Dr. Benjamin Berger. He's the one that is directing the expedition. So, Dr. Berger, this is the first time I've been able to go on an expedition here in the United States. I mean, I've done day trips. I've done day trips, but I've never done like the full camping thing, except in South Africa. So give me, and give my wife also, an idea of what the Eocene is, and then we can talk about what sorts of things to expect in Wyoming of that time.
Yeah, definitely. So the Eocene period is a period goes from about 56 million years ago to about 34 million years ago. So it is about 10 million years after the dinosaurs have gone extinct. And it's part of a period of time called the Paleogene, which is the earliest part of this period we call the Cenozoic. The Cenozoic is often sort of the age of mammals. So we have the age of dinosaurs, the Mesozoic, and then we have the Cenozoic, which is the age of mammals that follows.
And that's the only thing that people ever seem to know, or they don't even know really that much, but it's usually just these two segments of time.
Yeah.
I want to throw out there that there is another one. When I was in South Africa, we were doing we were doing the Permian. And so I have to explain to people that, no, this was before dinosaurs, and then they get confused.
Yeah. So that's the Paleozoic. So it's actually pretty simple. There's Cenozoic, Mesozoic, and Paleozoic. So there's the recent life, the middle life, and then the ancient life. And the middle life is the one everybody knows because that's the one with dinosaurs, or I should say non-avian dinosaurs. So the big iconic dinosaurs like Tyrannosaurus Rex, Diplodocus, all those guys were living during the Mesozoic. And so we're looking actually at the time afterwards. And when a lot of people think of the Cenozoic, they usually think of the ice ages. They think of the Pleistocene or Pliocene period of time. And oftentimes they're thinking of places like in Africa and East Africa, where a lot of the early hominids are found. But the Cenozoic is a very long period. It's 66 million years, and we are still in the Cenozoic. And what's interesting about the Cenozoic is it's really divided up into kind of two time periods. There's the early part, which is right after the dinosaurs go extinct. And that's when the climate was really, really warm. In fact, it was slightly warmer than it was in the late Cretaceous.
Now,
And in
what was the name of this? There was like it's called a thermal maximum or something
yeah, so
like
there's
that.
a number of these climatic events that are happening in the Eocene. There's a major one that happens at the beginning of the Eocene, a big global warming event called the Paleocene-Eocene thermal maximum. And there's a couple other events that we call them hypothermal events, where global temperatures increase quite dramatically, sometimes over short periods of time of a few thousand years, and then sometimes over longer periods of time. So there's a lot of climatic stuff going on during the end of the Paleocene, beginning of the Eocene period of time. So the types of fossils you find in Wyoming are things that you wouldn't expect to find there. So there's a good chance we'll find a lot of crocodile and alligator type material. Most of these are extinct crocodilians near the split between crocodiles and alligators that are found there. Lots of tropical sort of animals that you would tend to find in places like the Amazon forest today. In fact, we'll be finding a lot of turtle fossils. There are fossil fronds of palm trees, things like that you wouldn't expect in Wyoming, indicating that the temperatures rarely got below freezing in the winter during the Eocene. It was a much warmer period of time. And
that's an interesting thought that finding fossil pine trees and crocodiles in Wyoming of all places.
Yeah, palm trees and things like that you wouldn't typically expect to find there. One of the really interesting ones is we find a snail fossil that's Biofilaria. Biofilaria is like a little snail, like coiled snail. And it's funny because today it's considered an invasive species in the United States, even though it has a fossil record here. And part of that is that it's confined to South America today, but it's been introduced into places like Texas, where it's considered an invasive species, even though there's a fossil record of it extending all the way up into Wyoming during the Eocene time when it was much warmer. This particular area we're going to used to be an ancient lake system. And that's what
it does not look like it from the beautiful photograph that you sent me, which by the way is on my screensaver now. I love that picture that you took of the site that we're going to. I'm like, this is incredible. They should film, live action Wile E. Coyote scenes in this in the scene that you gave. It clearly doesn't look like there was a lake system or really water at all.
Yeah, today it's just high dry desert. It's on the continental divide. The Great Divide Basin, which is kind of to the north in the Red Desert, it's internally drained so that the water that flows in just evaporates and disappears. So it's a very dry climate today. In the winter is brutally cold. We're not too far from Little America, which is actually named after Little America in Antarctica because it gets so cold there in the winter. So it's kind of an inhospitable place today. But back in the
absolutely barren. I saw the video. I watched the videos that you shared with the group, the other people that are going on this expedition, to show just how open it is, where you can walk across all the when you find yourself on high ground on the hilltops and everything, and look around, and you can't see a road or a house or a fence or just a sign of humanity. I'm like, that's impressive, because where in the United States can you ever be and not see a hint of humanity?
Yeah, that's Wyoming and parts of Utah. Yeah, very different than Texas. But yeah, it's kind of a cool area because it's got a long paleontology history as well. The Transcontinental Railroad goes right through this area, and in the 1860s, when they were building the railway through, they picked this area in part because it is fairly flat. And the Shoshone Indians that were there, led by Washakie and some of the folks there, like Jim Bridger, were usually peaceful to settlers on the overland trail coming across. The Pony Express came through that area. So it was a well-traversed area, and today I-80 zips through there. But a lot of people just zip along the highway or ride the train, and they don't see like the get out into these areas, into these basins away from the highway that just are really incredible, fun and interesting places. The first fossils found in there were in the 1860s by actually Joseph Leidy, who was one of the first vertebrate paleontologists after the Civil War, came out with his wife and started collecting fossils of some of the locals that had sent him fossils as they were moving out there, and locals started finding cool things in the desert and sending him back east, and it attracted the interest of O.C. Marsh, the famous dinosaur paleontologist, as well as Edward
From the Bone Wars.
From the Bone Wars, and they both came out. Marsh led a field trip with his students from Yale I think in 1872. Came out with a bunch of his students, and they collected all sorts of cool stuff. And then Cope actually came out that summer as well. He was not associated with the university, so he was just kind of out there by himself collecting. And then there were a lot of surveys that came through, like the Hayden survey with the geological surveys of the West that were funded by the U.S. government through acts of Congress to basically map certain regions and explore certain areas. And it's from that area that they explored the Yellowstone region to the north, did a lot of work in Utah and Colorado as well. And that area became kind of a central hub for a lot of people coming across country, heading to California on the Transcontinental Railway. So it was easy for visitors from back east to ride the train, get off at a train station. We'll actually go through some of the old train stations that they used to hop off, and then just you could get a stagecoach and go out into the desert and find fossils. So there's been a really long history of fossils being collected from that area of Wyoming, even though it is really considered a very remote area. It's probably even more remote today than it was back then.
In talking to my wife about the sort of fossils that we could expect to find, knowing that it is North America, I wanted to throw some things out just for point of contrast. I mean, at this point, in other parts of the world, and even along at least the east coast of the United States, or the east coast of North America, you would see, from this time, you would see transitional whales develop, for everything from the earliest forms in Pakistan up to the transoceanic, the first ones that still had four legs, but were obviously capable of at least following a coastline, if not crossing the entire ocean independently. So there were transitional whales there. Of course, we're not going to find those in Wyoming because it's not coastal. But then otherwise, there was some interesting things going on in Asia. And I think at this time in paleohistory, the most interesting stuff was going on in South America, because you had the last of even though the dinosaurs were all extinct at this point, you have the last surviving vestige of the crocodilomorphs, the non-crocodilian crocodilomorphs, which, just for people to have any idea what these things are, imagine the way dinosaurs were depicted in the 1920s. That's what the crocodilomorphs actually looked like. So huge, slow-moving, bipedal, cold-blooded, crocodilian-looking things, not the high-speed, intelligent, rapid movement, powerful and lightweight dinosaurs that we know them now. They were
during the early Eocene, you had like pseudo huge mammals like the Creodons, like the pseudo crocodilomorphs. Kind of look like a crocodile.
You're confusing two things there.
Okay.
Crocodilomorphs and Creodons, very different.
I know that.
Benjamin. I know you do. I know you do. Benjamin, we had Creodons in North America, right?
Yeah. So there's a good chance we'll find some Creodons. So one of the weird things about the Eocene is that the types of mammals that we start finding in the Eocene, and actually this is true of reptiles as well, is kind of a mix of modern mammals that we would be able to place at least into an order, or at least into a modern group today. So for example, rodents are found during this period of time. So we'd be able to find a rodent that is a rodent in the same family as the squirrels are in today. At the same time, there are other animals like creodonts that are no longer have gone extinct, and that are found during the Eocene. So it's a mix of what we call archaic mammals as well as more modern type of animals that we have living today.
If I had to describe a creodont, I would say something that is very close to a carnivoran. So if you want to think about wolves, bears, big cats, something like that, but with an almost reptilian intelligence and something that would be impossible to tame, and that's something that was not as efficiently built as carnivorans, so it's not as fast. It couldn't go as far.
And there's two types of creodonts. There's the Oxyhinids, which are kind of wicked. How to describe them? When they were first discovered back in the 1870s, they thought that they were the ancestor to sea lions because they have like their big carnivore, sort of shorter faced predators. With big canines. They have rows of, the Oxyhinids will have a single carnassial, but it's in a different position than the carnivores. And they're kind of, there's one called Pantophilus, Pantophilus, and it's Patrophilus, and it's kind of a big kind of carnivore tiger-like animal. There's another group of creodonts, and those are the hyenodontids. The hyenodontids are smaller fox-like creodonts, and they have rows of carnassials. And later on in the late Eocene, they get really big. And so
that's the only one that I know. I mean, hyenodon is like famously huge.
Yeah, and it's kind of more like a hyena today, although it's in a completely different order. There's also another group of predators that are fairly rare, and it'd be really cool to find one, and that are the Mesnickets. The Mesnickets are a group that lived kind of.
Those were American.
They're found in America. Mesonics is an American fossil found actually in the Bridger.
I'm sorry. No, I was thinking about something else entirely. I did what my wife just did. Like accidentally swapped two names in my head.
No, I didn't. I said the Morphs weren't crocodiles, and Creodonts weren't the mammals we know today. So they're
Gotcha.
that's an extinct order, right?
Yeah.
Yeah.
Yes.
Order
What I had done,
mammal,
what I swapped in my head was a non-Eutherian, non-Metatherian early egg-laying mammal that still persisted after the Cretaceous Paleogene extinction. I can't remember how long these lasted, but it was like one lineage of these egg-laying mammals that survived for a time, and that's just what my brain just synced to the wrong word.
I'm maybe wrong on this, but were the Mesnickets relative to whales?
Yeah, so it's kind of an interesting story. So Mesnickets are they range in size from sort of fox size, and then some of them get really, really big. And some of the larger carnivores that were existing during the Eocene. So they had Andersarkis, which is the famous one, and I'll talk a little bit of Andersarkis because it may not be an actual Mesnick.
Yeah, I was going to bring that up because my understanding was that there was a thought for a while that whales had derived from Mesnickets, and now they're thinking that it's not. It's closer to the Entelodonts and the Andersarkis, but Andersarkis is itself not a Mesnicket.
Yeah, so it's kind of an interesting story. So in the 1960s, there was a paleontologist named Leland Van Valen, and he was at the University of Chicago, I believe, and he ended up writing a famous paper on the origin of whales. And he proposed that Mesnickets would be a good ancestor to whales. And at that time, there was very little early whales. I think at that time, probably Basiosaurus was probably the most primitive whale that they actually had fairly complete skeletons of it. So it's before Pakicetus and some of these ones that have been discovered since then. And so he published a paper in the 1960s, I think actually like in 1960, arguing that Mesnickets were the ancestor to whales. And part of that was based on a specimen of this Mesnicket, possibly Mesnicket from Asia called Andersarkis that had been discovered in the 1920s by the American Museum on their expeditions into the Gobi Desert. That discovered Velociraptor and all these really cool animals in the Gobi. And it's a huge, humongous skull. It's only known by one specimen, this huge, enormous skull. And so there's a lot of similarities with a big skull like that with some of the, big whales, the big toothed whales in particular. And so, that kind of crept into everybody's opinion that was the ancestor to whales. Beginning really in the 1990s, there was a lot of researchers that started working on early whale evolution and going after some of these sites in Pakistan, in Egypt, especially around India, those areas where some of these fossils were discovered in the Eocene. And their big discovery was that they got some of these early whales that have hind legs and had the bones of the hind legs. They started studying the anatomy of the hind legs, and they instantly recognized that it doesn't have the same anatomy as the Mesnickets do. The postcrania, the bones of the ankle in particular, are different in Mesnickets than they are in these early whales. And in fact, the bones look very similar to artiodactyls. And so they started looking for within the artiodactyl clade of mammals for possible ancestors. And they started to point out some of these artiodactyls actually make a better ancestor for whales. Now, Andersarkis is kind of interesting because it's only known from a skull. We don't have the postcranial, we don't have the foot bones of Andersarkis. And that means that telling if it's actually a true Mesnicket or if it's an artiodactyl maybe has been sort of contentious. So everybody's interested in finding more of the skeleton of Andersarkis, because if they find more of the foot in particular is what you need, and the astragalus bone in particular, if it is like an artiodactyl, Andersarkis might be an artiodactyl, and hence, fairly closely related to the advent of whales.
We have to note that these animals have very similar skeletons, and so we're looking for what is the difference between them. Because I realize that some people watching this from the outside would think that we have entirely different skeletons, but they're actually very close. And there's only one or two traits that would distinguish between a Mesnicket or an artiodactyl. And then the artiodactyls, while they were looking at all these physical traits, I'm doing this for the sake of the audience, while they were looking at all these physical traits and realizing that this may be closer to the artiodactyls, and artiodactyls include hippopotamus, pigs, and both of those represent a whole lot more than we still have alive today. Everybody needs to understand. There's what we call like the pig group is a whole lot bigger than you have any idea about.
Are hooved animals, right? Or
I'm sorry, what?
Yeah, these are all hooved animals.
Yeah,
so they
all hooved animals.
And
so that would include like cattle and deer and giraffe and all of these sorts of things. But I mean, hippopotamus is in that group, and then they get the genetic feedback for comparing genomic whole genome comparisons, and they realize the closest living relative to whales is the hippopotamus. So that came as a surprise, except if you were already comparing these skeletal traits and realized no, that figures.
Yeah, it was kind of crazy. So what ended up happening in the 1990s was there were two things that happened. There were some molecular studies that were being done at the time, doing basically DNA and looking at what are called like total evidence or phylogenies, using collecting DNA from all the living mammals that they could find, and then running an algorithm to see which ones have the most similarity with each other and pairing them up. And in the early days, there was a lot of like, a lot of times they didn't have the sequencing that they have today, and they were using mostly proteins a lot of times. And so they get some weird combinations, and the paleontologists would kind of laugh that off and like, yeah, well, those guys could be related. And when they discovered that hippopotamuses, which are artiodactyls, and whales kind of grouped together, seem to share a common ancestor, there was a lot of, in the paleontology,
which did not look like a hippopotamus.
Exactly. And one of the weird things too with hippopotamuses, they have a fossil record that kind of goes into the Miocene, and then kind of, they don't go all the way back to the Eocene. So this presented a lot of problems. And what ended up happening was Hans Theeuwen, who's done a lot of work on this and still does a lot of research on whale evolution. He I think it was like 1990, maybe early 2000, 2001 or so, he ended up finding the ankle bone, the astragalus bone of one of these early whales. I can't remember which one. I think it was Paraxial, and presented it at the meetings. It became, I think, a science paper, and it really demonstrated that the ankle morphology, the shape of the bones, was very similar to what you find in artiodactyls, which is where hippos belong to. What then a lot of people did was they said, well, Mesnickets might be actually very closely related to artiodactyls. And so this, making this distinction between whales evolving from artiodactyls or whales evolving from Mesnickets might be just sort of, well, Mesnickets have a lot of features that artiodactyls have as well. And really kind of the more recent research has been pushing them further into artiodactyls, which is really surprising. But then we're discovering that some of these fossils we thought were Mesnickets might be actual artiodactyls. So that's what kind of causes all sorts of these issues.
I do like the option that we could discover Mesnicket, because I mean, that's one of the things that I find kind of fascinating, that you would have a hooved predator, such a thing we do not have today. I mean, trying to imagine something the size of a bear or whatever, that has a different it doesn't have carnassials, but it has teeth that fill that role. It has effectively fangs, but it runs on hooves.
Was it the largest land mammal predator?
That's a good question. Whether, I believe Andersarkis probably is. It's difficult to estimate the size, and one of the things that's really interesting about it is that a couple people have done some really nice reconstructions of it, more modern reconstructions of Andersarkis, and have reconstructed it more like a pig. So pigs have really big heads, but kind of smaller bodies. So if they did that, it would make it a little bit more smaller if it's more pig-like. A lot of the Mesnickets that are true Mesnickets, like Mesonics, are very fox-like, wolf-like in appearance. They have very long, kind of narrow scales. Harpolestes is a really cool one, known from fairly complete material. And it's got
just imagine a sheep in wolf's clothing.
Yeah. They have very long snouts. They're very slender. They're very quick, so they're running predators. They have some really interesting things in their ankle that are actually kind of similar to what you see in horses with their astragalus bones. So it's slightly different than artiodactyls, but they have what's called a paraxial hooves. So the hooves actually look like kind of like what you'd see might be in a pig. The weird thing is that during the Eocene, there are some artiodactyls that actually have claws. So it gets a little confusing when you're looking at the digits of some of these animals.
So
sure.
when we're talking about artiodactyls, we're talking about the even even
The
number of toes.
Ungulates, yeah. So this includes
Ungulates.
pigs, camels. It includes
Deer.
cows, deer, antelope. Lots of things. Let's see what else. Or the major moose.
You just said artiodactyl.
Yeah, so artiodactyls encompass all of those guys. They are
One
often
thing that I'd like people to understand is that when we talk about the closest living relative, the hippo to the whale, then the whale, because when people mention mesonics, so when they mention Mesnickets and they use mesonics as an example, and they say that this wolf-like creature was possibly ancestral, then well, now the people hear that and then they think it's a wolf. So you think that a wolf turned? No, I didn't say wolf. I said a wolf-like, and I only mean superficially wolf-like.
Yeah.
It's like the size and general shape of a wolf kind of thing. And then when we say that the hippopotamus is the closest relation to the whale, again, we're not saying whales came from hippos. And if we say that it's an artiodactyl, and artiodactyls includes cows, then we get all these illustrations of the cow swimming with the dolphin in the ocean as if but no, it wasn't a cow. It wasn't a cow. It wasn't a hippo. It wasn't a wolf. We're talking about things that don't exist anymore. And we're just trying to take superficially something that would illustrate what this thing looks like.
Yeah,
But there are still some living artiodactyls. And what's the other group? The something dactyls that are odd-toed like horses.
Yeah, so you have the even-toed. They have the two hooves. Sometimes they're called the cloven-hoofed. So those are the artiodactyls. And then we have the odd-toed. The odd-toed has one or three. And there's actually only 3 groups of animals that are living today that are we call parasidactyls. That's the other group. Those are the odd-toed ungulates. And those are horses, tapirs, and rhinos. So horses have
and there were lots of intermediates once upon a time.
Yes, and in the Eocene, they're actually parasidactyls are more diverse than artiodactyls during the Eocene. So one of the groups we might find are members of the Brontotheres or Titano Theorists.
Oh, I like those.
Yeah, so they are.
That's imagine for the audience. Imagine a huge rhino that has a double bladed shovel instead of a horn.
Yeah,
yeah,
they're really cool. They're very diverse in the Eocene. They really thrived. There's a good chance we'll find Hyrachiris, which is a running rhino. They're actually more closely related to rhinos, but they look like horses. There's something we call swamp rhinos, which are Amblyodon, which is I don't know if we'll find those. Those tend to be a little bit more rare where we're going, but you do find them, and they are kind of like they look like hippopotamuses. And they're a group of parasidactyls that were living during the Eocene, another group that went extinct and got quite large. And so the parasidactyl group was much more diverse. We also might find some early horses, like Orohippus, which is a little early horse that's much smaller than horses today. So this is
now is this going to be a 3-toed horse?
Let's see. Orohippus, I think, has the full complement. I think it might have 5. I'll have to look it up. Everybody asks me toes, and I always have to remember each of the genus.
I remember that the one they call Eohippus or Hyracotherium, the reason they call it Hyracotherium is because it has this odd toe assemblage where it has 4 toes in the front and 3 toes on the back, which is very weird. And the Hyrax in Africa coincidentally has that same arrangement.
Yeah, I have to pull up. I think it's got all 5. Let's see. I'm going to pull a picture. 1, 2, 3, 4, 5. Okay, it's got 3 in the back.
Whenever you hear the name hippo in a scientific name, it's usually a horse. Like Eohippus is the dawn horse.
Yeah, Greek for horse.
That's something we could find in North America. And because horses and cats and dogs developed here.
Yeah, so horses have a very long fossil record in North America. They are pretty abundant in the Eocene. So like Eohippus is really common in the early Eocene. And then you get into Orohippus kind of as we get into the middle Eocene. There's actually a couple genera in between there, depending on what classification you use. And then as you go into from the Eocene into the Oligocene, there's kind of a big extinction event that happens at the end of the Eocene, kind of a changeover. And then they almost go extinct in the Oligocene in North America, but they hang on with one genus. And then during the Miocene, there's another big, huge diversification of horses. And that's when you get the really big megahippus and some of the really large horses. And then they, in the Pliocene and into the Pleistocene, they go extinct in North America around 11, 12,000 years ago. And then the modern horses were reintroduced. So it's kind of funny. We will, when we're out there, we'll see a lot of Mustang. There's a lot of wild horses out there. And the BLM always is rounding them up. And talking to the BLM, they're always like, they're invasive. And then you go,
the Bureau of Land Management.
Yeah.
Yeah.
They're invasive, but you go, they actually have a fossil record extending millions of years in North America. And they're very successful today. And there's kind of a mystery of their extinction. And why they actually went extinct a few thousand years ago in North America, maybe overhunting, habitat changes, things like that. But they're doing quite well today, and they're often
similarly.
Mm-hmm.
Similarly, it's amusing to me that genetics and fossil record reveal that the African cheetah evolved here in the in North America, and is more closely related to the American puma than it is to the African big cats.
Yeah, there is an American cheetah, and then
but that's much later. We're not going to find, for example, I'm wondering, would we find what is the predecessor, a sister group predecessor that are like almost cats? I can't believe I can't think of the name.
So it's kind of interesting. So carnivore systematics has been shifting a little bit. John Flynn, who's done a lot of work, and some of his students have published some new phylogenies that have kind of shaken things up a little bit.
Nimravids. That's the word I'm looking for.
Yeah. So there's the Nimravid. So we kind of think of, carnivores in a very general sense of kind of like there's cats and dogs, but then there's also bears, and then there's weasels, and we kind of add all these other groups. In the Eocene, it used to be that they kind of grouped the true carnivores into the Vivaravids and the Myacids. The Myacids were considered the dog-like carnivores, and the Vivaravids as the cat-like carnivores that were existing in the Eocene. And of course, then you also had Creodonts and these Mesnickets we were talking about. They were fairly large.
The Myacids and the other group, Nimravids, they have descendants today, whereas Creodonts don't.
Yeah, so then the Nimravids evolved, and initially they thought they evolved from the cat-like Vivaravids, but now people think that they evolved out of the Myacids, the dog-like ones.
That would be very confusing because, Barbarophilis, just to take one example, it is a scimitar cat. It's just, as I understand it, like subtle bones in the middle ear or the inner ear is the only difference between it and a cat. And when you look at Barbarophilis, most people would confuse that with a Smilodon.
Yeah. And what's crazy about Nimravids is they have a lot of cat features. They have retractable claws. They are the first saber-tooth cats. So they predate the, Smilodon, the big...
The scimitar cats.
Yeah, these guys, they're often called the false saber-tooths. Another way to name the Nimravids. Hopiophonus is kind of the classic one, and it's found in the Chadronian, which is the latest part of the Eocene, particularly from the White River Formation.
And like during the later part of the Eocene, the climate started to cool, so you would see, like in the early part, like with a dawn horse, the Eohippus, that this horse was the size of a cat, right? Because the climate was hotter. And maybe they were better able to regulate their temperature, smaller animals.
Yeah, and these guys were, they were dog size, cat size. They were small, but then after, especially as you go in towards the end of the Eocene, when we get a lot of the other carnivores start to die out, like the Mesnickets go extinct. In North America, the Creodons go extinct at the end of the Eocene. And the carnivores, the true carnivores that we have living today, that include bears and cats and dogs. They also include a lot of the marine mammals as well, like seals. Those guys really kind of started to diversify and got bigger and got more diverse, particularly during the Oligocene, the period right after the Eocene. And that was maybe due to some of the extinctions of some of the other carnivores, especially the larger carnivores.
Well,
like
the cooling period, where there was a glacier started to develop, because if you look at the Earth behind me, that's the Eocene. Don't see ice caps there. And how do we know this? Like, kids will answer this question. It's a fair question. You can find fossils in islands in the Arctic with subtropical or tropical plants,
so
animals that you wouldn't expect to find in the Arctic Circle. So there's not an ice sheet there.
Yeah. In the Eocene, there are some amazing Eocene sites in the high Arctic. My old advisor did a lot of work in the Nunavut territories, like in Ellesmere Island and some of those areas. And there are Eocene deposits up there, fossils. It's really interesting to see what types of fossils they find and which fossils they don't. The types of plants and animals that are living up there include plants like Metasequoia. We might find some Metasequoia. It tends to be a little bit rare down in it's particularly this period of time. Metasequoia starts dying out. Metasequoia is a relative to the redwood trees that we have today. They are a really fascinating plant. They were thought to be extinct worldwide, but they have been cultivated in China, where there was some that were discovered and sort of cultivated, and they've been reintroduced into North America. And people can grow them in their yards nowadays. But Metasequoia was this conifer tree that's very common up in the high Arctic during this period of time. And it kind of looks like a pine tree, but the needles are kind of broad, fairly broad needles on it, if you ever see one. And they grew up in the high Arctic and were kind of adapted to that type of environment. So it wasn't necessarily tropical, but much warmer. There were a lot of Crippadon, which is another Eocene mammal that's like a hippo-like animal that was living up there. They're you can find them to the south as well. They find, let's see, what else do they find up there? I'll have to think of some of the other mammals that they find up there, but they find, a variety of different animals. They're really curious of what would live in that type of forest versus what's further to the south. It's a little less diverse than what you find in more southern areas, that would be more tropical, but no ice, no ice at the high Arctic, although it was subjected to the darkness of the winter and then the long days of the summer up there around the Arctic Circle. But yeah, there's no evidence of any glaciers during that period of time. In fact, we haven't found any geological evidence of glaciers as well during the Eocene. So it's pretty ice-free period of time.
And what about bear dogs and dog bears and that sort of thing?
Yeah, so
that's going to be later, right? Those are Oligocene.
There was a paper that came out recently that has argued that some of these early guys might be within that family that are found in the Middle Eocene. So we could find some of the ancestors of the bear dogs, which would be cool. I would love to find one of these more rare carnivores. Last year we found some cool stuff that I was hoping to be rare carnivores, but they're more common things. So yeah.
I heard of a sloth bear. Was it a bear?
Oh, that's a good question.
Sloth bear is Asian.
Okay, so not in North America.
Yeah, and it's extant, so it's not. There's something that lives there now. Yeah, we have used. We originally budgeted an hour, and we've gone 45 minutes just talking. And we've been building up this list of questions. We've got a moderator that's picking out questions from the chat. And I think we probably should dive into those before we get too abusive of your time. Honey, do you want to take these?
Yeah. Hive Science. He or she asks, did I miss them talking about North Arctis? North Arctis.
Let's see. North Arctis? No. Is it North Arctis?
It's spelled NOTHARCTUS.
Can you see the questions in the private chat, Benjamin?
Yeah, I can kind of go through. So I typed in North Arctis for you guys. So North Arctis it's NOTHARTCUS. I have not talked about North Arctis. North Arctis it's a genus of a primate that's found during this period of time.
In North America?
In North America. It's like a lemur-like primate.
Oh, okay.
It's a really cool primate. And it's got folio-opposable thumbs. It's
a North American fossil primate.
Yeah.
And a strepsirrhine at that. So we're not talking about something. We're not talking about like a Central American monkey, New World monkeys or whatever.
That's
You're talking
cool.
about a strep. What?
Would that be something we might find?
Yeah, definitely.
Wow.
North Arctis is pretty common in the Middle Eocene. It would actually be kind of cool to find some. We haven't been finding the two areas we're going. We haven't found very many of them, but they have been reported from the area. They are they belong to a group called the Adapid primates, and the Adapids, which includes North Arctis. Another genus is Smilodectes, which is fairly common. Another one a little bit older is Cantius. And those are all like these little lemur-like primates. They look like kind of ring-tailed lemurs. They're found in Madagascar today. And they were fairly common in the forests during the Eocene. And so you do find them. In fact, the primates can be really useful for figuring out the age because they're very diverse. And a lot of the species don't have long temporal ranges. So when you find a fossil primate, they can tell you pretty precisely what actually age you're in the subdivisions of the Eocene. And North Arctis is very common in the Bergerian and first appears at the beginning of the Bergerian. And there's some beautiful skeletons that we have found over the years. I've done a lot of work and some of the specimens that that we've collected over the years have gone to the American Museum that have them on display. And they found really remarkable skeletons of these little guys. The other group of primates that we might find, which would be really cool to find, are the Omamayid primates. And these are smaller tarsier-like primates. And they are, because they're really small, you usually find their jaws or sometimes their bones. It's rare to find a complete skeleton because they're pretty small, so they tend to break apart. And they look a little bit like tarsiers that live in Southeast Asia today, but really big eyes. They're nocturnal. They were good leapers and climbing around trees eating insects, whereas the lemurs were eating plants. But both of them are primates, so they have opposable,
Do these also exist in South America, or did they come over from Europe?
So it's a good question. So tarsiers today live in Southeast Asia. Omamayids have been found in Europe, Asia, as well as North America. They have been found in North Africa. There's some things that look like they belong within this group. And then recently there was a tooth that was found in South America. Now, South American monkeys that live in South America today, like the squirrel monkey, they are anthropoid primates. So they're in the group that's more closely related to African primates that are living today. And so there's the two groups of South American monkeys and African monkeys. And they appear in the Miocene in South America. It's believed that they somehow rafted across from Africa, sometime during the Oligocene or Miocene, maybe when sea level was down as we got these glaciers, and was able to make it over to South America, and they've sort of been able to spread throughout South America and into Central America. What's interesting is that this fossil that they found in South America that might be an Omamayid looks more similar to the ones in Africa than the ones in North America. For most of this period of time, South America was separate from North America, and there was no isthmus, Panama Isthmus. So there was no connection between the two continents. And
so that would explain why these look more like the old world varieties.
Yeah, and that really
because they're coming over from Asia and Europe directly.
Wasn't there a continent before it broke up called Laurasia?
Yeah,
what was it? The one with North America, Greenland, and Europe, right?
Yeah, so there's Laurasia, which is basically grouping North America, Europe, and Asia together, and with the idea that you could actually hop over continents across the Arctic Circle, right? So during the Eocene, you could basically walk to Europe, you could walk to China, going across what today is the Bering Strait, or going across what is today Greenland. Whereas today we can't do that. But today we can walk to the southern tip of South America, but during the Eocene, South America and North America were separate by quite a distance. And so a lot of the animals that made it into South America after the extinction of the dinosaurs had arrived there either right around the extinction of the dinosaurs. So a lot of the South American mammals that are living there in South America during the Eocene are very weird. Some of them look like there's a lot of marsupials. They look a lot, some look superficially like other mammals from other parts of the world, but are in their own classification or other group.
Are these Uintatheriums?
Some of them are Uintatherians. A lot of our Uintatherians are marsupial, but many of them are endemic South American ungulate groups that appear to have evolved separately, sort of hooves. And
are we talking about Meridiungulates?
Yeah, Meridiungulata, that clade.
Those are Uintatherian?
No, those are not Uintatherian. Sorry,
okay.
those are.
You were just about to confuse me. I was almost certain that they would.
There are lots of Uintatherians in down there, and even today. So if you look at the number of native marsupials, Australia beats everybody with pretty much every mammal there is marsupial for the most part that are native. And then in South America, they have quite a few native marsupials. And then here in North America, we just have one. So we just have the Virginia opossum. And in the past, in the Eocene, actually, there are quite a few North American marsupials. In fact, we might find some marsupials. And they were much more diverse in the past, and they've just slowly over time not become as diverse. And part of that was they were competing more with placental mammals in Laurasia. Yeah.
And having to protect a clutch of eggs that you have to leave at home. Yeah, I can get the math on that. We need to move to these questions because we are almost into an hour.
Here we go. There were super chats, but you showed them on screen, so let's get the ones that weren't questions. Okay. Jonathan Kennedy had a lot of good questions. He says, what I know about the Eocene is limited to Chased by Sea Monsters by Nigel Marvin, where encounters are Uintatherium, Dorudon, and Basilosaurus. And I think those are interesting because they're like giant predatory sea mammals.
Yeah, Uintatherium, you should look it up. You can Google it. It's got these massive horns on the tip of its nose. Uintatherium is it's a member of the Alphatherian group, and they are found in North Africa. In fact, all of those, I believe, are found in North Africa in the Eocene. Actually, Uintatherium, I think, is actually a Oligocene, and it's a really cool, weird creature, more closely related to elephants. And
though it looks like a rhino,
really cool. Found in Egypt, really neat area of Egypt that they're discovered in. There's a beautiful, the best skull of Eocene is actually at the British Museum. So, and it's found very close to where Basiosaurus, the early whale of Egypt, is found too, in kind of a similar area.
There, I did get mixed up because I saw Basilosaurus, and I
Yeah,
was thinking of the big sea mammal.
there's
But
another one that's cool that's found in the same deposits as Eocene, and that is Merytherium or Moriatherium, and that is a early elephant that's really cool looking. So yeah. And a great
What's the next
series
question?
too. Those are fun to watch.
next, moving along, Jonathan Kennedy. Speaking of Andersarkis, though, how do we know so much about it despite only having one large skull?
I don't know. I would say we don't know much about Andersarkis. I wish we knew more. There have been expeditions to try to find more fossils of Andersarkis, heading back to some of those areas in Mongolia. I know of a couple people who've attempted to find more specimens, and they just haven't been able to find more. It's a beautifully preserved skull, which makes it really, really interesting. So we don't have the lower jaw, just the upper part of the skull. But that's quite a bit to tell a lot of things. Like you can tell the diet, you can tell the rough size because we have the skull. So there's enough of it there that we can kind of make some inferences, but it'd be really nice to have a skeleton associated with it.
Is that the one that had a 3-foot skull?
Yeah, it's massive. Very massive skull, very broad cheekbones as well. So it's just really massive. And the teeth are just enormous. They were used for crushing whatever it was chomping on. So crushing bones, all sorts of stuff.
So just imagine a warthog the size of a camel.
Yeah. And Benjamin was just saying that they're not sure if how big it was because that skull could have taken up more of its body like a pig.
Yeah, or could have been really long, like to try to kind of picture what the rest of the skeleton looks like is hard when you don't have it. Mm-hmm. It's kind of crazy because Andersarkis is more rare than Tyrannosaurus rex. We have nice skeletons of Tyrannosaurus rex, but Andersarkis, we just have that one skull. So, yeah.
Isn't it funny how that works out? Now that implies that something about the environment, though, right? I mean, because there's certain environments that are going to be more fossiliferous or that have the better aptitude for fossilizing something. That if you live in a rainforest, almost nothing comes out of that in a form of a fossil.
Yeah, and I think part of it too with Andersarkis is that everybody knows Tyrannosaurus rex, so everybody's going out, collecting Tyrannosaurus rex. So there's a lot of people looking in those deposits, where there's less people looking for some of these more rare mammals, just because of interest, public interest too. So it's kind of funny because I think we have a perception that dinosaurs are really rare. And then once you do paleontology, you realize dinosaurs are they're pretty common. Like you can find a lot of dinosaurs out there. Some of the rare stuff are some of these really unusual mammals that people, the general public may not know about, but, specialists who are interested in mammalian evolution are focused on. It seems like paleontology, even among the professionals, kind of falls into either studying dinosaurs or studying early human evolution. Those are where like a lot of people focus on, and there's a lot of stuff in between, the evolution of dogs, the evolution of elephants, that don't get as much attention as they should.
Okay. Again, Hive Science, hello. She said, because she clarified, Pristachampsis was pretty awesome. They were carcereal hunters like modern dogs, highly mobile.
Yeah, I was going to mention Pristachampsis. We do, in this area, Pristachampsis is known to occur. In fact, there have been some skeletons found. They're really interesting. If you do find a tooth of a Pristachampsis in the Eocene, you kind of do a double take because the teeth look a lot like dinosaur teeth. They are serrated, long teeth, kind of like you would find in a theropod dinosaur. And they're kind of a more upright crocodilian that's running around during the Eocene, chomping on stuff. There is an episode, I think, of what is the old TV show, the British show. Probably somebody out there will remember it.
That reminds me, the reason that I chose the thumbnail,
the
the thumbnail that I did, I found a picture from 100 years ago that said that it's, this is Wyoming in the late Eocene, and I'm like, well, this is perfect. Yeah, but the depiction of all the animals is so bad. I mean, for example, they have Uintatherium, which is arguably the biggest thing we could find. And that was, to be honest, it was, or to be fair, that was a strange looking beast, but it probably didn't look like a fanged elephant with antlers.
Now, didn't you say Uintatherium is named after being found in that area?
It's named after the Uinta Mountains, same as our campus here. So the Uinta Mountains are kind of the big mountain range that goes across northern Utah and Wyoming. And so they named it Uintatherium when it was found. Joseph Leidy found the first one. He's the one that actually came up with that name, Uintatherium. Marsh and Cope both came up with names as well for the creature. In fact, it might be Cope's reconstruction because he sort of thought it was an elephant. It's actually really interesting in phylogenies. Uintatherium tends, because it's just so big, it tends to have a lot of characteristics with elephants. So a lot of times it superficially looks like an elephant.
How big is it?
It's big. There's at the museum here in town, we have there's a couple that they've reconstructed, and I would say they are like the size of a large bull, maybe a little bit bigger. They're rhino size. They have very wide bodies as well. So they're the pelvis could be like 4 or 5 feet wide. So they're very big. In fact, when they made the models, they discovered they couldn't fit it into the room that they were supposed to go on display because they made them too wide. So they had to kind of slender them down a little bit to fit them in because they're so big. So they and one of the things about Uintatherium, when you do encounter a skeleton, they are very large, and usually it's a big operation to actually excavate a Uintatherium, like a dinosaur, because they are very large, like a sauropod dinosaur. And you do stumble upon them every once in a while. And they're known from this area as well. So yeah. And what's weird about them is that they coexisted with some of the Brontotheres as well that were very large. In fact, some of the Brontotheres got to be rhino size as well. So these were some big mammals. So they get up there with the dinosaurs, in terms of size. Not the sort.
I don't know exactly what it was, but the Brontotherium was my favorite of all of the.
They're cool.
All of the Cenozoic fossil mammals. I don't know what I dug about it so much.
They're really cool. Henry Fairfield Osborn, who named Tyrannosaurus Rex, his real love and what he'd really dedicate most of his research on was on Brontotheres. And he worked on them quite a bit more than Tyrannosaurus Rex, which is interesting. And during the 1920s, 1930s, there was a lot of interest in Brontothere evolution and Titano evolution in the group. And people kind of thought that dinosaurs were, they were big lizards and they're dead. But these guys were, mammals, and they were more interesting to study. And there's a lot more fossils, so you could ask a lot more questions and stuff. So they attracted quite a bit of interest in that period of time. So there's been a lot of research on them.
Somebody just put in the clarification of why it is that I preferred the Brontotherium is because the name means thunder beast.
Yeah.
Of course. All right, so let's get to the next questions. We gotta get through these.
How close is this trip to Douglas, Wyoming? My great aunt had property there, and we found lots of petrified wood there, all sizes.
Yeah, Douglas, Wyoming is to the kind of to the north and west. It's a bit of distance from it. There is actually some well-known White River deposits of the later Eocene, the Chadronian, around Douglas, Wyoming, in that area, further to the north and to more central Wyoming. So yeah, it's a bit of a distance. I would say maybe 100 miles, no more, probably 200 miles from Douglas, but cool place. I think Douglas has the Jackalope Festival every summer that my wife always is like, we should go to the Jackalope Festival. If you know what a jackalope is, they're the guys with that you see taxidermied with the I think pronghorn or antlers on the bunny. So they have a festival up there in Douglas.
Okay, when are we going out to Wyoming? Someone asked Robert Templeton.
Yeah, late July.
Well, let me put that another way. We leave here on the 15th. I've got to meet with somebody in Amarillo on the evening of the 15th. Then on the 16th, I will be meeting with. I'm going to be doing a meet and greet with the Denver Secular Hub. So I'll be in Denver, Colorado for that, and I don't yet know what the specifics are for the Denver Secular Hub, but I know that they're going to be taking us out to some of the local microbreweries and all that after their official get-together. So there will be an address somewhere for that. And then on the 17th, I'm supposed to be in Laramie, Wyoming, to do a radio show called Interesting If True. And I know that there was some people that wanted to do some kind of a meet and greet there also. And I'll make sure that, again, that I broadcast on social media what the addresses will be for that as well. And then on the 18th, we will head out from Laramie and meet up with Benjamin, and then turn off the beaten trail and disappear into the wilderness forever.
Okay, next question. What is the age of the strata you will be hunting on your trip to Wyoming?
The age of the strata that we're going to be looking at is about 47 million years old. There are a few dated ash layers that have been dated. And there's also some really nice paleomagnetic studies that have done to date the rock layers. So about 47 to 48 million years. So it's in sort of the middle part of the Eocene. So yeah.
Okay. Hive Science will Arn debate me on the superiority of the compound eye?
I probably not, because I would have some idea what I'm talking about.
Okay, next question. Were the mid-latitudes of Asia and U.S. of tropical climate during the Paleocene and Eocene?
Yeah, and we define. I should preface it and say that based on the plants, the fossil plants, it's sort of subtropical, not quite tropical like you would find in sort of Central America today. So there were a mix of plants that live today in wet, sort of places like Louisiana. So you usually wouldn't say Louisiana or even parts of Texas as being tropical per se, but definitely places that don't necessarily get in the winter get below freezing. So that allows for crocodiles and palm trees and some of these more tropical types of plants. Usually it's referred to as subtropical rather than necessarily tropical per se, based on the plants and stuff. But definitely much warmer than Wyoming today, and much wetter as well with these lake systems. So, and forested too, with deciduous forests that were had all these primates and other animals running around. So very diverse too, the types of things that you find during the Eocene. It's a really diverse time for life on the planet. So.
Okay, next question. How far down do you have to dig to find fossils of the Eocene, and where are the majority of Eocene fossils found in the U.S.? They say they apologize if it was already covered. They came here late.
So usually what we do, so there's two types of paleontology fieldwork. There's one which is what's called quarry work. That would be like going out to a site where there's an active quarry. So it could be with mammals, it could be with primates, it could be with plants, whatever fossils, where there's a certain area that you go out and it's an active area where you're splitting rocks, digging in the rocks in a kind of a pit, and finding fossils that way. The other way of finding fossils, which is what we're going to be doing, is what's called surface prospecting. And that is where you kind of wander the desert and you look at the ground and you're looking for any evidence of things weathering out of the ground. And typically, one of the nice things with mammals is when you do find a mammal, they tend to be smaller than dinosaurs, and they tend to be easy to jacket, to excavate. And usually the excavation part of it doesn't last more than a day or two. And then you excavate it and get it out, and then you take it into the museum to prepare it. Sometimes I've been on some places where you will come across an area that needs to be excavated, and there'll be a lot of bones, and the fossils are considered really important. And then we'll excavate. And usually to excavate, especially where we're going to be, would have to put in, get permission, and get a collecting permit to do an excavation of that size. So it just depends on the size, and survey it and get permission to do that. So surface collecting oftentimes is wandering around and looking at the ground and looking for any fossils that could be found. And it depends on the area, but this is a desert. So a lot of times you find bones and stuff eroding out. And most of the fossils that we find are sort of like little isolated skeletons, or sometimes a skull or something that's eroding out. It's maybe a little bit similar to what you experienced in the Karun Basin in South Africa too, where you're wandering around, you find something. They might have a few areas that you might be able to get down and actually excavate. So we don't have any quarries right now in the area we're going. So, which is kind of nice, because quarries are kind of a pain you have to stay in one area. It gets hot digging down usually with jackhammers and moving a lot of rock. So quarry work can be kind of intense.
Okay, next, not a serious question, I think, but if Arn had to fight a saber-toothed tiger or a Kodiak bear, naked and unarmed, what would he pick? Saber-tooth or Kodiak bear?
I'm gonna die either way. Doesn't
I don't
matter.
know. It's hard to pick between
All right,
the two.
next questions for our guest, please.
How many species of hominidae have we discovered, and what can their bone structure tell us about our own? Hominidae.
The Hominidae
Well,
family.
those are great apes.
Yeah.
So there are, I think, 50. Is it somewhere around about 50? No, there are. It depends on how we categorize it. So orangutans, and this includes Gigantopithecus, and there are like right now there's at least 2 species of gorilla. There is technically 3 species of chimpanzee, 2 species of or at least 1 species of bonobo. And it just depends on how you categorize these. When you get into the fossil record, well, now you've got all the Australopiths, which include the Paranthropines, and there's a host of others. And then when you get into the earlier groups, there's earlier groups of hominidae that are not immediately familiar to us. And these include some habitually bipedal, very primitive versions of not yet chimpanzees or gorillas. They're not yet that group. I'm wishing I could remember the name for that subgroup, or that parent group. But there were at least 50 species. Dryopithecus. There was at least 50 species of Dryopithecus known just by themselves. So we've got a couple of hundred different species at least in Europe and Africa and Asia.
Yeah, and the hominid family. So you're using the family term, which is the IDAE. There's also the hominoid, which are the superfamily, and then the hominine, which is the tribe. that's even a more exclusive group. And so there's kind of three categories that are more and more refined and excluding more and more. And so there's actually quite a few species. And then, of course, at species level, with a lot of the early humans to human evolution, there's a lot of debate of what constitutes a species. So some researchers, one of the things that paleontologists tend to do, they get really excited when they find a fossil. And so instead of identifying it as a pre-existing species, it's kind of cool when you can name a new species. So a lot of times when a new discovery is made, it gets named new as a new species. And then over time, they start like, maybe it is part of this species, or no, maybe it's different. And then there's a lot of back and forth with the number. So sometimes
they name things wrong. Like Basilosaurus should not be Basilosaurus. Basilosaurus should be Zogalodon. It's a mammal, not a reptile. Fix that. But we can't because tradition.
Yeah. So that's so when they discover a fossil, and it's a new fossil, you can't find any other examples of it. You want to give it a new name. There's a holotype that's named, and then there's the genotype. And so, and whatever is the one that's first used, it has priority. And so that's the one that kind of enters into the lexicon.
I found a beautifully preserved skull cap when I was in South Africa that was just magnificent, and it had the fenestra, the pineal fenestra, and it was wonderfully detailed, but it wasn't enough of the skull to make a determination. It wasn't enough that I could name the thing. Of course, you kind of have to have teeth. Yeah, you have to have enough that you have teeth before I could come up with a name. But people were asking me if I had an opportunity to name something when I was out there at that time, what would I name it? And just for shits and giggles, I thought, okay, well, if I do get a chance to apply my own name to something, I'll choose the name Kofefi.
No, don't honor that man.
Well, now, of course, if I have the same opportunity, and especially if it's one of these like indeterminable things, because you have things that are, is it on the cat side? Is it on the dog side? Is it Nimravid? Whatever, because everything they blend together. They come so close to each other that you can't tell. Is it an Artiodactyl? Is it a Mesnickets? So this time around, if I get to find something and I get to name the species, the name is going to be the fuck is this?
Now, someone was telling me it works differently. Like you just can't name something if you find it. Like whoever identifies it in the lab.
So basically the way it works is that you have to publish on it. So when you discover something new, you write a scientific paper and it has to get published. And then once it's published, then it's in the literature and it's now sort of officially accepted. One of the issues then is what constitutes it being published. And there is there's an organization, a nomenclature that kind of keeps track. There's a number of groups like Zootaxa that are indexing. So when you do name something, you can actually then submit the paper, the manuscript, saying this is actually the species and this is the holotype. A holotype has to go into a museum, and that's the type specimen that other people will look at. You can synonymize them later on. So another researcher may come along and sort of say, no, I think that's the same thing as this fossil, and synonymize it. Later on, somebody may split it out. But that publication serves as sort of like a voucher that's actually naming it. So typically there are some like etiquette, I guess, in naming things, although they've gotten more and more lax over time. It used to be you'd publish it and it had to be Latin or Greek. But nowadays people can use any language. In fact, people have been kind of pushing it, especially some of the Chinese researchers. I think like getting things that are almost impronounceable, which is kind of problematic. But in any case, you come up with the name, and then the official name is the genus, the species. It's a binomial name. And this is a system that Carl Linnaeus came up with back in the 1600s to categorize life on the planet. So you have a genus, a species name, and then usually the authors of the paper will be in the official name. So you'll see that often listed in like online sites, like the Tree of Life and things like that. So that's how you go about doing it. Oftentimes people, in fact, we're going to be going to a colleague of mine who found a fossil where we're going to be going, 5 or 6 years ago, and they named it after Lady Gaga. So a little Artiodactyl. So you can name it after whoever you want.
Well, you got to be careful with that because somebody had named a planet. And this kind of like started a domino thing. They didn't name it after a Greek or Roman god. They named this dwarf planet Xena, and they named its moon Galadriel. And this had to be a huge honor because Xena is not a character from ancient folklore or whatever. This is a TV show in the 1990s, and it has been portrayed by exactly one actress. So you have effectively named a planet after Lucy Lawless. And while
sadly, it never stuck because they didn't allow them to do that. But it was
I know. I was getting great giggles out of that, and then they said, no, we're not going to do this. You don't even get it. You don't even get to call it a planet anymore. We're going to recategorize everything. I don't care that it costs us fucking Pluto, right? Where we are not going to have the planet Xena. No, and so now they call it, like M469 or whatever.
I think it's serious.
Yeah.
So the cool thing is there's not a committee to name things. So it's whatever the author comes up with, which means you get stuck with some weird names. So, and those are the scientific names. So everything, all plants, all animals, even bacteria, viruses, all get a binomial name that's registered. And so it's done a little bit different in botany. And you always have to find a unique name, especially the genus name has to be unique, which can be problematic. Oftentimes you think you came up with a great name, and then you find out that, there's some insect that uses the same name. So the genus name has to be unique. So that's why some have got kind of a little unique. Sometimes they come up with a really good one and they find out there's an insect that's named that. And so they'll change the spelling just slightly, things like that.
Well, if they're going to break tradition, let me name something. Let me just name it Binky, and just the binomial. It's Binky.
It's really challenging too to talk about animals using their scientific names because everybody pronounces them differently. So oftentimes when you're talking to colleagues, you kind of talk around each other because you're trying to figure out how to pronounce a certain scientific term or scientific name.
We started this show. I mean, you are from Uinta, mountains, but I had never pronounced those. I called it Winta. So I'm demonstrating what you're talking about.
Yeah, exactly. So a lot of times you kind of know the local way of pronouncing things.
And Washachi was what you said. I think I'd never seen that word before either.
That one's impossible. That one's I forget what tribe it's based on. It's a really bizarre fossil. It's believed to be a primate that lived in North America. It's found in Oregon, I think in up into the Miocene. It's a really weird fossil. Anyway, you can never pronounce the name. Egma what Sashawish?
All right, we are going to have to fire through these questions because we're coming up on an hour and a half.
There's only 2 left.
Okay, good.
I think an interesting side note on the naming of the planets, I mean, I guess it's a nod to the mythology and the people that discovered them. But, like, what if sometime in the future it's like, well, what if we don't want to call it Jupiter? He was a jerk, and his captured moons, it was rapey, like Ganymede or whatever, and Europa, and we could call it Ginormous McGassy Boy or something. Yeah. Okay, here we go to the next one. Arn from Robert Lawrence, thank you for the donation. Arn, could you share pictures of any interesting finds on your adventure? I hope you all have a safe, fun time.
Well, when I went to South Africa, I was the videographer for the expedition. And so I was taking pictures constantly and doing video constantly, and of course all of that I made videos of all of that. I didn't show the boring bits, as Benjamin mentioned, that the larger animals can take quite a while to excavate, and I think we spent 3 or 4 days trying to get a Scutosaurus out of the ground, and what a big pain in the ass that was. Imagine something it looks like a turtle without a shell, and it's the size of a cow. And have fun getting that out of the ground. They were able to see like these 2 arm bones basically to identify, and they're uniquely distinct. So they knew right away upon looking at the tibia and fibia that they knew what a species it was. And then we dig around the whole thing, find the whole thing, plaster the whole thing, and then we're out there with a jackhammer and everything for 2 days like that. And I got pictures of all of that, and all of us trying to lift this damn thing into the truck, because that was a bucket of chuckles, let me tell you. Yeah.
Okay. Next question. How fossil rich is the site you will be hunting? I live in southeast Indiana, close to Cincinnati, where Ordovician fossils are common, so it's hard to imagine a place where fossils are rare.
Yeah, the fossils are pretty rich. I love this area. There's 2 reasons that I love working in this area. And one is actually, you do find stuff. You can find stuff closer to town. In fact, where I'm located in Utah, there's some sites that I work at that are just, half an hour down the street, that you can go out to and explore and find fossils. And they're Eocene fossils, and you find really cool stuff. The nice thing about this area is that you tend to find a little bit more complete stuff. Part of that is that it's a very vast area, so there's not as many eyes on the ground. And so in some areas where there's a lot of people out looking and stuff, you tend to find less, especially when it's easy access. The other thing I love going out to this area is just its remoteness. It's a really beautiful area. I've worked in some of the other basins where, they have active construction, well pads going in. There's like dirt roads everywhere. There's people on dirt bikes and ATVs and stuff. And, you can find fossils there. In fact, there's a site that's that I think is even richer that's in town. That's an incredible site, but it's just like, there's people out there all the time and, riding around in ATVs and stuff. But yeah, you can find fossils anywhere. Some of the most incredible fossils have been found actually in cities. I've done a lot of work as doing consulting, so salvaging fossils that are found during road construction or housing construction, where they're digging up a big pit and they come across a mammoth or something like that. So you can find really incredible fossils kind of wherever you live.
There's a park at the end of the street that we live on. And after a storm, you got a creek that goes through the park. And so whenever there's a storm, whenever there's heavy rain, the water comes up. It takes a lot of the topsoil away. The creek widens out, so there's a lot of erosion. You go down there after a good storm, and that's going to be fresh dirt that you're looking at. And so there was a school bus driver who was a young Earth creationist, believed that the Earth is 6,000 years old. He thought that dinosaurs were a hoax. And he himself personally wanders down to the creek just because, and sees an exposed mosasaur in the cliff by the creek. So he's discovered the mosasaur, a thing that he thought, where do you think that came from? Do you think the devil buried that? Did God put there to test your faith? How do you think that got there?
Yeah, you can find all sorts of crazy things. Like, definitely, I tell people, like, a lot of people are like, oh, you have to go out in the desert to find stuff, or go out west, and you can find things like as long as you're looking at sedimentary rocks. So sedimentary rocks are going to be the ones that have the fossils. So and you're not house is not near a volcano where you have igneous rocks, or sitting on granite, or sitting on really, really old sedimentary rocks, where you're not going to find any large sort of visible fossils.
Desert environments, I want to advise people about that too, because
deserts are great.
Grass will destroy any exposed, if you have exposed fossil layers and there's grass growing in it, when, plant life has a tendency to bust up concrete, as you know, it busts up fossiliferous, deposits as well. So you're not going to find many fossils where there is grass. That's why we go to deserts more often.
And a lot of times, the two places that are really good for finding fossils are beaches. So going by a beach, because there's active erosion happening a lot. Deserts, where there's a lot of times there's a fair amount of wind action that's causing erosion too in deserts. The other good places I've seen are like river banks. So where there's active cutting into a roadside, a creek side, or road cuts where they've actually come through and cut through into the rocks, and you can actually get to the rocks, the bedrocks. If you're
that was where Neil Shubin found his like definitive fossil. Despite all these expeditions to Greenland, his most famous fossil was found, or one of the ones that he based a lot of his work on, the important, Saurischius, the evolution of the hand, that was found on the side of the highway in the erosion of a cliff that they had to cut to build a road.
Yeah. So those are great places to look. In fact, you often will see geologists like scattering out those. They pull over. Oh yeah, I gotta look at these rocks, and we get mad when the road construction comes and they cover them up with like concrete or whatever. You're like, no, we want to see those. They do it to prevent landslides onto the highway, but those types of places are a great place to look for fossils. So you want to look for the bedrock, right? So the rock that's below the topsoil. So, in your backyard, you got to kind of dig down below the topsoil to find the good fossils. Although oftentimes the fossils will weather out into the topsoil. And so you can find fossils they're being weathered out, bits and pieces. But the key to finding really good fossils that are more complete is to make sure they stay in the rock itself, because as soon as they start eroding and crumbling out of the rock, then they're very fragile and they'll bust apart. When the really incredible fossils that you see oftentimes in museums were encased in rock that helped protect them, and then they were very carefully prepared in the lab to expose them so that they don't completely fall apart. We'll probably find a lot of fragmentary bone, bits and pieces of things that we know is fossil, but we don't know what type of fossil it is, so we usually don't collect it just because it was a fossil at some point that's just broken apart through erosion. So, yeah.
I expect to make a lot of video out of this expedition.
There's one more question, and I have a question after that.
Okay.
The question is, in the movie Jurassic World, they explain the inaccuracies of the dinosaurs in the first movie, Jurassic Park. Was that they brought in a scientist from the first movie? I kind of am not getting that.
I haven't seen the new movie, the new Jurassic Park movie. I keep trying to convince
the excuse or the explanation that they gave was that because they couldn't get complete DNA, they had to fill in with the DNA of a frog. So if they had complete DNA, he said that many of these animals would look very different. That's why the velociraptors are all naked.
Yeah,
because frogs don't have feathers.
That's the problem with a lot of these movies that base themselves on a lot of the science. The science, of course, changes, and we make new discoveries. And so
it was just another reason I chose the thumbnail that I did. If you look at the thumbnail, that ridiculous elephant with antlers, what the hell were they thinking?
Yeah, and it's funny because a lot of times these old reconstructions are really fun to take a look at, because the fun one I always talked about my students is Stegosaurus. When Stegosaurus was first discovered, they found the plate and they thought it was a turtle, like a sea turtle. And then they found, some other bones, and they found some other bones. And it wasn't until they found a complete skeleton that they were able to put together what Stegosaurus really looked like. And early reconstructions of Stegosaurus were just all over the board. They had no idea what this animal was. They thought it was like a plesiosaur type animal. Then they found the spikes. They didn't know exactly where the spikes were. They didn't know where the plates were they laid flat, where they laid. And it wasn't until they found a really nice, beautiful skeleton, the roadkill specimen that was found in Colorado, that's at the Smithsonian Institute. Once they found that, then they had a really good complete skeleton with the bones where they were supposed to be. But a lot
a
of
similar story when they found all the ichthyosaurs. They thought for the longest time that ichthyosaurs were something like a crocodile, that it's something that would be like wading in the shadows kind of thing, that would have to, like a seal, that would have to crawl out on the land to give birth and everything. But then there was this one fossil, and they found a handful of fossils like this since then, that give the impression where the animal dies on its side, and its dorsal fin and its tail fins, the flukes on the tail, all of these things were preserved. And now you've got the skeleton and you see the outline of it, and they say, oh crap, that's not this is the reptilian version of a dolphin.
Yeah.
This is not at all what we thought it was.
Yeah, for sure. Yeah. And the cool thing about paleontology is every new discovery, you add a piece to the story. It may be a new species, it may be a new part of the anatomy of an animal that we only have a skull of or only have teeth of. So every discovery is kind of something new that adds to the general knowledge. So yeah.
So I'd like to discover an Andersarkis, since nobody has any post-crania. I'll find the body of the Andersarkis and I'll discover the dorsal fin.
I know. There's so many things. have a long list of stuff I would love to find too. And every time you always find something completely unexpected too. Every time I go out in the field, it's, you think you're going to find something. I am horrible at identifying things in the field. Oftentimes I'll think that we have something. I put in my notes, my collecting notes and everything, keeping track of everything. I'm like, okay, I think this is a skeleton of a Creodont. Get back to the lab. We open up the jacket, we start prepping it. And pretty soon, you start looking at the bones and you're like, wait a second, this doesn't make sense. And then you're like, oh, this is what that is. So oftentimes, it isn't until a lot later on when you prep the stuff and you compare things that you realize what you're actually dealing with sometimes. Yeah.
I think that sounds like a good note to close this out.
Well, I said I had a question.
Okay, that's right.
Aaron was saying that maybe we wouldn't have to worry about mountain lions, bears, or in Wyoming, in that part of Wyoming, maybe just rattlesnakes. But you said there's horses.
Yeah, there's the two animals we'll see a lot of are mustangs. There's a lot of horses. In fact, in getting permits and permission to go out there, we have to make sure that we don't harass the horses. They monitor the horses in the area, especially the second camp we're going to be camping at. There's an area where they monitor the horses closely. There are lots of pronghorn out there, antelope.
So why wouldn't there be carnivores?
There are mountain lions. Most of the mountain lions are going to stay in the more wetter areas. They tend to be in the mountains more and hunt deer. They tend not to be able to be fast enough to catch the pronghorn. So the mountain lions, like most of the mountain lions that I've run into, tend to be up closer to the mountains, or they tend to be in more of the canyons. We could run into mountain lions. Mountain lions tend to be very quiet and very difficult to even know that they're there. So most of the time people don't even notice there's a mountain lion.
That's the sad thing. I've lived in places like that where you take your kids out for a walk and you have to be very, very, very attentive about the kids. Yeah. Because these cats will appear out of nowhere. You have no idea, and you only have a second to respond. So
would there be coyotes?
There's tons of coyotes. We'll probably see lots of coyotes, and you hear coyotes at night. This area, there is a fair amount of coyotes. When I worked to the south, I remember we set one camp when I was working on my dissertation research, and I swear there was probably like 50 coyotes that would come into camp at night and howl around.
Yeah, I sometimes heard them when I lived in Odessa. Whenever they caught something, they get really pitched and scary sounding.
Yeah,
they're little dogs.
We'll hear them definitely at night. There's a lot of coyotes. There are not very many bear. Most of the bear are further to the south, they tend to like, well, they really like to feast on some of the fruit trees and bushes and things like that are more alpine. I have seen bear, and there are bear that go down into the book cliffs or canyons that they'll come down, but they tend to like the wetter areas as well. I've never seen any bear out there, so we don't have to worry too much about bear. Yeah, most of it's the the horses. We had one of the camps we're going to be at. One night we had a bunch of Mustang, like a herd of Mustang, in the middle of the night come running through camp, which is a bit terrifying.
Yeah.
When you're sleeping in a tiny little, we're going to have a very tiny tent, per your advice.
Everybody's scared of the predators, but a horse can throw down if he's mad. Yeah.
But there isn't too many predators. I've rarely seen rattlesnakes in this area.
Good. That's good, because I was particularly worried about that.
Yeah, we'll keep an eye out for rattlesnakes. But
it's just going to be so remote that if my wife were to come with me on this trip, and we get up, step out of the tent in the middle of the night or whatever, and now she gets bit or whatever, then it would take what, an hour to get to town?
Yeah. So we'll have a snake bite kit with us. I've never seen rattlesnakes in this area. Usually most of the rattlesnakes tend to be in some of the juniper and pinyon tree kind of areas. They like to go after the small rodents that tend to be more common in those types of areas. The badlands they kind of avoid. Sometimes in the springtime, like in May, you get a lot of rattlesnakes that are coming out of hibernation. And so sometimes they'll go into the rocks to find places to hibernate. But most of them, I worked in southeast Colorado where the rattlesnakes were everywhere. They were just everywhere. And I've never seen a rattlesnake where we're going. But there are some. There's a species of pygmy rattlesnakes. They're native to the area, but they're pretty rare. So most of the bigger rattlesnakes are found kind of further to the south. I think it gets too cold for them too. Usually
I got lucky when I was in South Africa. They told me that that there are adders and there are cobras, and I'm thinking 8 hours a day, every day of the week, I'm out there, wandering around kicking over rocks looking for fossils. I'm gonna find an adder or a cobra. And surprisingly, I only happened across an adder once. But there's places I know in Arizona, places where I used to live, Arizona, New Mexico, West Texas, where you could not walk around in the desert for any day, for 8 hours that whole day, and not stumble over a half a dozen rattlesnakes.
We lived in Dallas, and this was once more like what you're saying. Even in the Eocene, a lot of stuff was swampy, but there should be coral snakes, and there's a rattler here, and I forget which one, and there's copperheads and water moccasins. But when I lived in Houston, they were building a new subdivision behind my dad's house, and they were always driving copperheads and water moccasins out of there. But the weird thing, I didn't expect to find them in Nebraska. Not poisonous. It wasn't poisonous, but I didn't expect to find a snake in Nebraska. And I went there last month. Taught one of my kids move, and I go on the front porch, and it's like a quad apartment in a subdivision. And I looked down, and I was like, "Is that a snake?" Because you're always doing that with snake-like objects like garden hoses and stuff and branches. Is that a snake? And I'll be doggone if it wasn't a snake. And I freaked out, and I go, "It's a snake." And the snake freaked out too. I think I traumatized the snake because it was like writhing everywhere. Like it didn't even be able to move. Like it looked like it had a seizure writhing. I scared the shit out of it, and it went back into the grass it was hiding in. And I was like, I didn't even think there were there, because in Texas, when you go places, you might even find some to see, but we don't have that many in our subdivision around our house. I've just seen small ones, but
not anymore. We used to
Yeah.
have quite a few rat snakes and gopher snakes and that sort of thing. Right? I used
You
to
know
catch
where to put
snakes all
your,
the time.
you know, watch where you put your feet.
Yeah,
You know,
yeah.
Nebraska, I didn't expect the snake scared me. And I'm sure he was a great snaky boy doing his snaky boy business, and he was a bad boy, you know. But it might have been a girl, you know. but he's scared because I didn't expect to see him there, and I didn't think it would really be a snake. And then it was moving like crazy, and I was like, stop doing that. That's weird.
My wife has never lived in a place where they had a lot of colubrids. and I have, so I just
It might have been
I
a
remember
garter snake.
I used to go down to the like the river, you know, even in Arizona, we would go down to the river for a picnic or go camping or whatever, and I would go down to the river and just come back with hands full of snakes that I caught along the river's edge as a kid.
Yeah. My daughter's the same thing. She has a pet snake, and she goes and catches snakes all the time. Yeah, she loves snakes. So.
All right, I think we've got it. I don't want to be abusive of your time. We will have a couple of weeks to talk to you more about all of this. We just wanted to make sure that we were fully prepared before we get so far out into the boonies, and I think we are. I think we are going to be really well prepared. My wife has had Army training, and she got a grocery list of things that I never even thought about for the kind of conditions that we're going to be
fair, we had like outhouses though. So we don't have access to water here or a place to go to the bathroom, a designated place to go to the bathroom.
It's a remote area, and some people really like doing field work in remote areas, and other people, they kind of get a little, after a few days, they're like, okay, it's nice having a shower. It's nice having a bathroom. It's nice having some of the amenities. Last year we went out and we stayed in hotels, but that meant that we'd have to drive like an hour and a half each day. Well, an hour and a half to the site. We could only do the northern part because it took us so long to get there, and then turn around, around 5 o'clock and drive all the way back into town. So it is a very remote area. There are some places that you can do. I've done field work. I just actually got back from Nevada where we stayed at a hotel, but we were still driving, like an hour to get to the actual site where we were working, and then having to get back in the car and then make that drive back. And you look at the how much driving you're doing in the gas, and you're like, oh, that's using all of our budget to drive back and forth from the field site. So that's nice. The nice thing about camping, once you get established there at the field site, you don't really do much driving. Everything's within 10 miles of that initial camp. And you just drive when you get into town to get supplies. So yeah. It's fun.
I'm really stoked about this trip. I've never been that remote. I've never had to camp that hard. I've never had to have the privy tent inside, which is just a bucket with a toilet seat on it. It'll be the first time I've ever had to do all of that. But I'm still excited. I'm still excited to have the experience.
Yeah, it's a lot of fun. So I love camping, and so it's a fun area too. It's a great area. I've taken a lot of students out there and had quite a few adventures in this area. So it's a fun area.
I got a pair of binoculars that you can handhold that you don't have to use on a tripod to check out the sky maybe a little.
Yeah, stars are amazing. There is no city lights within a couple 100 miles. So that's the one thing that really strikes you when you go out, is that especially on clear nights, you can see everything. It's really beautiful. And so, telescopes, a lot of people bring out telescopes and stuff because the night sky is just incredible.
We're beginners. We have a telescope, but I don't know how to set it up. So I got binoculars that we don't need a tripod for, so we can hand steady it, because the bigger they get, the harder they are to keep steady enough.
Yeah, that's true. And of course, you don't want to bring too much stuff too.
Yeah.
But the night sky is amazing. It really is amazing.
All right. We're gonna have to close it up. I want Benjamin. Thank you very much for being on. I don't know what happened to Donald. Prothero was going to be on, and I haven't been able to get any word out to him. Hope he's all right. But thank you for being on, Benjamin. We're looking forward to meeting up.
Yeah, definitely. It'll be fun. Getting excited about it.
Me too. We'll see you then.
See you then.